Hi, in today's examples, we will be trying to see if two events are independent or dependent. We're also going to be looking at outcomes as being mutually exclusive or inclusive. So as we start, we talk about events being dependent if we have more than one event. And what it means to be dependent is if the first event has an impact on the second event. Examples of this would be pulling marbles out of a bag and not replacing them, so that when you do the experiment the second time, you have a higher or lower probability of getting the same result. So those are dependent events. Independent events are events where the outcomes are not related. So if you pull a marble out of a bag and you put it back, or pull a card out of a deck and put it back, or maybe you do two completely different things like spinning a spinner and rolling a die, or flipping a coin and rolling a die. One event has no impact on the other, so those are independent. Also, you could roll die more than once, or flip a coin more than once. Those would also be independent events. Some of these events are easy to tell, whether it's dependent or independent, based on what it is. Sometimes it's a lot more difficult, and that's why we have this definition or this formula to figure out if events are independent or not. If you can take the probability of A and multiply it by the probability of B, and that gives you the probability of A and B occurring, then those events are independent. If that doesn't work, then they're not independent. So looking at this example, I have copied over this definition. It says the probability of A occurring is 0.3, the probability of B occurring is 0.8, and the probability of A and B occurring is 0.25. Now, if these are independent, A and B would be what we get when we multiply the probability of A and the probability of B. But 0.3 times 0.8 equals 0.24, not 0.25. So these are not independent. And this example looks very similar. I give you this definition again, but this time it says these events are independent, and we are going to use the independence to find the probability of A and B occurring. So we take 0.4 times 0.8, and when I multiply that, I get 0.32. So that is the probability, since these are independent, of them both occurring. We talk about inclusive and mutually exclusive when we're talking about our OR statements. So one event that can have multiple outcomes. So an event is inclusive. The outcomes are inclusive if two or more outcomes can occur at the same time, like a number being 2 and even. 2 is an even number, so those can both occur at the same time. Mutually exclusive are two or more outcomes that cannot occur at the same time. A number can't be a 2 and a 5, so those are two disjoint or two completely separate outcomes because they have no overlap. So if events are mutually exclusive, then we have the probability of A or B occurring is the probability of A plus the probability of B, because there is no overlap. And that's why before, when we were doing these, there may have been an overlap and we would have had to subtract out that overlap. So if there is no overlap, we don't have to worry about it. We can just add their probabilities. All right, so in this question we are asked, are these events mutually exclusive? And here's the formula again. The probability of A is 0.3. The probability of B is 0.28. And if they're mutually exclusive and I add up these probabilities, so I get 0.32 0.58. That should equal the probability of one or the other occurring, which it does. So I can say, yes, these are mutually exclusive. So this question says, are the two events described below dependent or independent? And they don't give me any probability, so I just have to think about the scenario. If I toss a coin, and then I toss the coin again, do the results of the first event impact the second one? And no, it doesn't matter how many times I toss a coin, I'm always going to have a 50-50 chance at getting heads or tails. So this question, these events are independent. Right, this question says A and B are independent. Find the probability of A and B occurring. This is one where you're going to have to use that equation to find the probability of A and B if you're given the probability of A and the probability of B. So I'll give you a second to do that. Okay, so the probability of A and B occurring, we take A, which is 1/6, times B, which is 2/7. When we multiply fractions, we multiply across the top, which is 2. Multiply across the bottom, which is 42, which reduces to 1/21. And this one tells me to enter the answer as 3 decimal places. So that's why 0.048 is my answer. And for this final example, it says if A and B are mutually exclusive, and if the probability of A is 0.25 or is 25% and the probability of B is 43%, what is the probability of A or B? So again, you're going to have to use the mutually exclusive formula. And if two events are mutually exclusive, to find the probability of A or B happening, we take the probability of A, which is 25%, add the probability of B, which is 43%, and because they are mutually exclusive, that's going to be our answer, which is 68%. That concludes this video. If you have any questions, ask me in class.